This next section is very calculation heavy because what we're going to be doing is interconverting between units of molarity, units of molality, mole fraction, and density. We're going to be taking, if we know part of them and we want to find out other pieces of that information, how do we go about manipulating these numbers so that we can get from one type of concentration unit to another type of concentration unit? In the example that he gives you, he makes it look kind of easy, but it can be a little tricky just because there's so many different things to consider. And so what I want to show you is a way of using a table to organize the information so that you are able to sift through the information that you've been given and be able to come up with the information you need in order to calculate the information that they've asked for. So we're going to be looking at three specific characteristics: the mass, the number of moles, and the volume. And we're going to be looking at three different species: the solute, the solvent, and the solution as a whole. Now, if you think about this, the solute, or the thing that is dissolved, I can have a mass of it. I can have the number of moles of it, but the amount of the volume of the solute really is not going to be anything that we're going to use. So that's a part of the table that's going to continually be left blank. Okay. The solvent is going to be the same way, because I'll talk about the mass of the solvent, because remember, in molality, we're talking about kilograms of solvent. I may have the moles of the solvent. We've already talked about that in mole fraction. But there is no place in any of these calculations where the volume of the solvent comes into play. So this part of the table is also always going to be left blank. Finally, I'm going to be looking at the solution. I can have the mass of the solution. I can have a volume of a solution, but the number of moles of solution doesn't make any sense because I've got more than one species involved there. Okay. So let's talk about the different types of things that we could be encountering. So let's start with molarity. I know that molarity is the moles of solute over the liters of solution, okay? Well, where is that located on my table? Well, moles of solute is going to be right there, and liters of solution, that's volume, and so volume of solution is going to be over here, okay? So that's where those numbers could potentially come from. How about if I look at molality? Well, I know that molality is the number of moles of solute per kilograms of solvent. So where are those located on my table? Well, once again, here's my moles of solute. My kilograms of solvent, that's going to be mass. So that's going to be up here, okay? I talked about mole fraction before. So if I talk about mole fraction, that's going to be the moles of either the solute or the solvent over the total number of moles that are in the species, okay? So here I've got the moles of solute and the moles of the solvent, okay? So that's where that piece of information is going to be located on my table. The other piece of information that I have is the density, and the density is going to be of the solution as a whole. And so the density is mass divided by volume, and so this number right here, I can get that from the density if I have enough other information. I can also get this from the density. I can get the total volume of solution from the density because it's mass divided by density. Sometimes when they set a problem up for you, they're going to give you the molarity, or they're going to give you the molality, but they won't give you both of them. If they give you the molarity, you can assume that you have 1 liter of solution. And I'll show you how that works here in just a minute. Similarly, if they give you the molality of the solution, you can assume 1 kilogram of solvent. And again, we'll do an example like that so you can see that. So this could come from the molarity, and this number could come from the molality as well. Okay, so really, as you can see, the mass of the solute's about the only thing that isn't going to come directly from some of the information that I have. Okay, so what you may want to do, as I work through this example, if this helps you, you may want to set this table up as you're working through your problems, because it will help you figure out, okay, what do I need? What do I know? What am I going to be able to find? Okay, so I'm going to erase this for the moment, and then we will start working through one of these examples. All right, so we're going to look at example 5.2. And example 5.2 says that I have a solution of silver nitrate, and it has a concentration of 1.2 molar and a density of 1.11 grams per milliliter. It wants to know the molality as well as the mole fraction of both the silver nitrate and the water. All right, so let's see what I've got here. I know that I have 1.2 molar silver nitrate, AgNO3. Okay, so it's 1.2 molar, and the density is 1.11 grams per milliliter. So what information from that do I know? Okay, well, if it's 1.2 molar, what that tells me is that I have 1.2 moles of solute for every 1 liter of solution. Okay, and just as a significant figure thing, a lot of times they're going to assume 3 significant figures in the volume or in the mass. So that's what I've noticed he is tending to do in his answers. So that's what we'll put in there. Okay, so again, both of these numbers came from molarity. This is 1.2 moles per liter, so it's 1.2 moles in 1 liter of solution. Okay, now if I'm supposed to find the molality, I need moles and I need the mass of the solvent. Well, how on earth am I going to get the mass of the solvent? Okay, what can I figure out? So let's start with that. Well, I know that if I have 1.2 moles of the solute, I can get to mass from there, right? Okay, so let's start with that. So I have 1.2 moles of AgNO3, and I'm going to calculate the mass from that. The molar mass of the silver nitrate is 169.9 grams in 1 mole. And so if I calculate grams, that's going to give me 2.0 times 10 to the second grams of silver nitrate. So I'm going to fill that in up here, 2.0 times 10 to the second grams. Okay, so that helped, but I still need to know the mass of the solvent. How am I going to figure that out? Well, I also know the density, which is 1.11 grams per milliliter. So I could use the density equation to figure out what the mass of the solution is, because I know the volume of the solution. So my density equation, if density equals mass over volume, I know the density is 1.11 grams per milliliter. I don't know the mass of the solution, but I do know the volume of solution is 1 liter, which is the same as 1,000 milliliters. Okay, and so therefore when I solve that, that is going to tell me that the mass is going to be equal to 1.11 times 10 to the third grams. Okay, I had 3 significant figures here. I didn't write them in when I put it down here, but I had 3, and so I'm going to put 3 in my answer. All right, so this is the mass of the solution. So that's going to go here, 1.11 times 10 to the third grams of solution. Well, if this is how much the solution is, and this is how much the solute is, how am I going to find the solvent? Right, all I have to do is subtract that. So if I subtract those two numbers, that's going to be 1110 minus 200, basically is what I'm doing there. And so when I subtract that, then I'm going to end up with 910 grams of solvent. Okay, see where that came from? It's this minus this will give me the grams of solvent. Okay, so there's the grams of solvent. Now that I know what the mass of the solvent is, they ask me for molality. Well, molality is the moles of the solvent, the moles of the solute divided by the mass of the solvent. So I can now calculate molality. So my molality is going to be equal to 1.2 moles over kilograms of solvent, which is 0.91910 kilograms. And so that, when I divide that out, will give me 1.3 molal solution, okay? So there is the first thing that they asked me for. The other thing that they asked me for is the mole fraction of both the solute and the solvent. Well, for mole fraction, I need the number of moles here. Well, if I know the mass, finding the number of moles isn't difficult because it's water. So if I have 910 grams of water, and I know that in 1 mole of water, there are 18 grams of water. That should actually have 3 significant figures there. 18 grams of water. When I divide that out, that gives me 51 moles of water. Okay, so I'm going to go up here and plug in my 51 moles. Okay, so 51 moles of water. Now that I know both of those, now I can calculate the mole fraction. So the mole fraction of silver nitrate is going to be 1.2 moles over 1.2 plus 51. Again, you've got to watch your significant figures there. So then that's going to give you 1.2 over 52 to the correct number of significant figures. And when I divide that out, that's going to give me 0.023 as the mole fraction for silver nitrate. The mole fraction for water is going to be 51 over 1.2 plus 51, which is going to be 51 over 52. Again, did the same number of significant figures, which is 0.98. Now, if you remember in the first video, I told you that if you add up the mole fractions, you should end up with 1. And so if I add 0.98 plus 0.023, that does give me 1. I mean, it's a little bit off, again, because of significant figures, but it's very, very close to 1. And so because those add up to 1, I can probably be assured that my answer is correct. Okay, so what I would like for you to do now is I would like for you to go ahead and try on your own problem number 5.2 on page 133 and see if you can work that by yourself. What I'm going to do is I will post a solution to that in video number 3 for this chapter. And if you need help, you can watch the video. But here's what I want you to do when you do it. I want you to start the problem by yourself. And then only watch the video at the point where you get stuck. And don't give up too quick, because again, this stuff is not easy. Don't give up too quick. But then when you get stuck, just watch it to the point until I help you get unstuck, and then see if you can go from there and finish it on your own. Okay, so the video is there as a resource. You can also look at the answer that he works out in the back, at the back of the chapter. I understand that sometimes, though, it's easier to watch somebody else work a problem than it is to try to read the solution. Plus, he's not going to use a chart like I am when he works it out. So if the other video is helpful for you, great, but be sure that you are also able to work it on your own first, okay?